Okay, so we're at the bottom of the ionic and covalent practice. We did the top part yesterday, and now we're gonna work through the bottom part. So the instructions say, identify whether for the following compounds, sorry, I totally read that wrong. Let's try this again. Identify whether the following compounds are ionic or covalent, then provide their formula. Remember to do the crisscross for ionic compounds, and covalent compounds do not need the crisscross. I'm gonna highlight that because that's important. So crisscross is ionic. The covalent do not need crisscross, okay? And we're trying to come up with the formula. So first of all, let's figure out if it's ionic or covalent. I don't know. Okay, whatever just beeped, if you guys could make that stop, that'd be great. Okay. First one, dicarbon tetraoxide. You can tell just from the name, without even looking it up, if it's ionic or covalent. Which is it? Yeah, it's covalent. You can tell because remember, covalent are the ones that use prefixes, ionic don't. So you automatically know based on the fact that this has prefixes that it is covalent. Good, and because it's covalent and they give the prefixes, we already know how many of each there are, okay? Yeah. Which one, what? Selenite? Say it one more time. Spell it for me. Or write it out. Are you looking for the element selenium? Oh, okay. That's in column 16. It's the third one down. It's SE. Yep. You're steps ahead of me, probably. But yeah, that's SE. That's selenium. Are you good now? Okay, good. Okay. Okay, so here we go. This is covalent. We know it because it has the prefixes, right? What does the prefix di mean? Di. If you don't know what di means, look at the prefixes. What is it? It's 2. Fantastic. So dicarbon means there's 2 carbon. What is the symbol for carbon? Yeah, it's just a C, right? So we're going to put C2 for dicarbon. And then the next one is tetraoxide. Oxide is referring to oxygen. So we're going to have O as our next one. What does the prefix tetra refer to? 4. So that's going to be C2O4. Good. That's going to be C2O4. And we know that because of the dicarbon tetraoxide. And remember, those prefixes are right here at the bottom right of your chemistry reference sheet. Okay. The next one doesn't have prefixes. What does that mean the type is? Ionic or covalent? Good. You automatically know it's ionic. And if you forget that rule and you want to check, you can always check your periodic table and see if it's on the metal side or the non-metal. Remember, ionic is a metal and a non-metal. Covalent is both non-metal. So you can always go back to that if you need to. Okay, so the next one, magnesium. What's the symbol for magnesium? Good, Mg. And arsenide is referring to arsenic. What's our symbol for arsenic? Good, it's As. So we know this one's going to be Mg and As. But the thing with ionic is we have to reverse that crisscross to be able to figure out how many of each there are. So magnesium, Mg on your periodic table is in column 2. Okay, so since that's in column 2, that means it's What is the number? The number of valence electrons that it has that it's trying to give away is 2. Okay, so we're going to put a +2 up here. Arsenic, AS, is in which column? That's in column 15, I think. It's in column 15, which means that it has 5 valence electrons. That means it's trying to give away 3. So that means it has an oxidation number of -3. That's the word I was looking for, oxidation number. Okay. Yep, and then you just crisscross those. So we should end up with Mg3AS2. Good? And we got that using our periodic table, okay? Okay, let's do another one. Strontium phosphide. Just by looking at it, it doesn't have any prefixes, which means it's ionic. Good. You can always check and find strontium and phosphorus and make sure that those are both, one's a metal and one's a non-metal. So strontium on the periodic table is SR. What column is SR in on the periodic table? Good. SR is in column 2 on the periodic table. So since it's in column 2, that means that it has 2 valence electrons it's trying to give away. That's that oxidation number. So we're going to put SR and we're going to put a 2 as its oxidation number. Okay, then we're going to do phosphide is referring to phosphorus. Okay, that's what symbol on the periodic table? That's P. P is in column 15. So since it's in column 15, it has 5 valence electrons. That means it's trying to gain 3. So it has a -3 as its oxidation number. So when we put P for phosphorus, we're going to put a -3 as its oxidation number. Then we're going to crisscross these numbers, and that will give us SR2 and P. I just janked that up, didn't I? Sorry. What should it be? Good. It should be SR3 P2. Hey ladies, can you guys pay attention or pretend like you're paying attention? Please and thank you. Unless you already know how to do this, in which case feel free to finish it up and you're good to go. Okay. Okay. Beryllium fluoride. Okay, is that going to be ionic or covalent? Ionic, how do you know? Yeah, it's just normal. There's no prefixes on it. Good. Okay, so beryllium, that's Be on the periodic table. What column is that in? Beryllium, Be. It's in column 2. That means it has 2 valence electrons it's trying to give away. Okay, so since it has 2 valence electrons it's trying to give away, we're going to put Be and we're going to put a +2 there. Okay, now fluoride is referring to fluorine, right? Fluorine is F on the periodic table. That's right here in column 17. So that column 17, that means it has 7 valence electrons. That means it's trying to gain 1 valence electron. So that oxidation number, because remember they're trying to add up to 8, that oxidation number for fluorine is -1. So we're going to put for fluorine a -1 up here. If those oxidation numbers confuse you and you don't know what numbers to put up top, you should grab the other copy of the periodic table that I have for you guys that just lists those out. So if figuring out what these little numbers up top should be is a struggle for you, you can get a periodic table that has them written above it. So these right here that they write above it are those oxidation numbers. If you want this kind of periodic table because it helps you, please feel free to grab one. Okay, they're up here with the other periodic tables. Okay, then you're going to crisscross these again. So this 2 will go down here. that -1 will go down there. So it'll end up being BE, the -1. We just put the absolute value of the number. So just BE1, F2. And then that 1 can actually go silent. You can just rewrite that as BEF2. Okay. Let's do another one. Cesium iodide. Is that going to be ionic or covalent? Good, it's ionic. Okay, keep going. Step me through it. Okay, good. Up here? How'd you get the 1 up there? Yeah, good, because it's in column 1 on the periodic table. Okay, next one. Okay. Okay, so iodide is in 17. That means it has 7 valence electrons. That means it's trying to gain 1. So you put a -1 up here. Good. So when you crisscross those will actually become silent 1s. So you don't even need to write them. That's how we got the CSI.
Is this nitrogen?
Mm-hmm. Okay. Yep, nitride is referring to nitrogen. Yep. Okay, next one. Keep going, dude. Sodium selenide. How do you know what it is and what is it? Good, it's ionic. How do you know? Okay. Okay, so sodium is in column 1. Good, so it has 1 valence electron. Selenium is Se. Yep. That's in column 17. Is it 17? I thought it's in column 16. I think it's in column 16. So good, because it's in column 16, because selenium's in column 16, that means it has 6 valence electrons. That means it's trying to gain 2, because remember they're supposed to add up to 8. Okay, so that's how he got the -2 that goes up here. Okay, so then when we crisscross those, what do we end up with? Good, Na2SE1. And the 1 can just go silent. So that's just Na2Se. Okay. The next one I know is covalent. How do I know it's covalent? Yeah, the Di in the front and the mono, those prefixes, those cue us in that that's covalent. So whenever you see those prefixes, you automatically know we're dealing with something covalent. What's another way that we could check and see if it was covalent? What's another way we could check and see if it's covalent? If both of them are nonmetals. Good. Oh my gosh. Hallelujah. Thank you. Okay, good. Okay, next one. So now we need to write the chemical formula. Dihydrogen. The symbol for hydrogen is H. The Di in front of the H means how many hydrogens? Good, 2. So there's going to be 2 hydrogens. The mono in front of sulfide means that when you write sulfur, which is just S, there's going to only be 1 of them. And we can simplify that and just say H2S. So notice all of the ionic, we had to do the crisscross thing. Ionic, we crisscrossed it. Ionic, we crisscrossed. Covalent, all we have to do is read those prefixes and we know how many there are. Okay, so next one. Lithium nitride. How do I know that that's ionic? Lithium is a metal. Nitrogen's a nonmetal. How else do I know that it's ionic? There's no prefixes. Good. Ah, thank you. Okay, so lithium, the symbol for lithium is what? Li. That's in the first column, so it has a oxidation number of +1, right? That means it has one valence electron that it's trying to give away. Okay, nitride is referring to nitrogen. What's the symbol for nitrogen? N. And which column is nitrogen in? Good. Nitrogen is in column 15. So since it's in column 15, that means it has 5 valence electrons. It's trying to gain 3. So that oxidation number that we put up top is going to be a -3 for the nitrogen. And now we're going to do our crisscross. We'll end up with Li3 in 1, and the 1 can actually go silent. You don't need to write it. Okay. Last two. Do I know it's ionic or covalent, and how do I know? Good. You know it's covalent, and you know it's covalent. Why? What is it? The Di in the front and the hexa, the prefixes, okay? That's an automatic sign that it's covalent. You could also double check by making sure they're both nonmetals. Okay, so dinitrogen, that Di means how many nitrogens do we have? Good, that means we have 2. If you don't know your prefixes, they're right here at the bottom of that chemistry reference sheet. So di is 2. So dinitrogen is there. Hexachloride. What does the prefix hexa mean? 6. So when I write chlorine, which is just Cl, I'm going to put 6 of them. Okay. Last but not least, phosphorus tribamide, I think is how you would say that. Tribromide, tribamide, I think is how it would go. Because it has that tri in front of it, we know it's what kind of bond? Yeah, we know it's covalent. Okay, the symbol for phosphorus on the periodic table is what? P. And because this is covalent, this normally would have the word mono in front of it, but we never put the word mono if it's the first element that's a mono. It's assumed then. So because this one doesn't have a prefix, but we know it's covalent, that means that this has an implied mono in front of the phosphorus. So there's only one phosphorus then. And then what's the symbol for, so bromide is referring to bromine. What's the symbol for bromine? Good, it's Br. And since it's tribromide, how many bromine do we have? Good. So we just end up with 1 phosphorus, 3 bromine, which you can just reduce that and write PBr3. Okay.